Hello and welcome back to Amsterdam. My name is Denise Lee. I'm the Vice President of Engineering Sustainability Office and Engineering Alliances here at Cisco. I don't have to tell you how important energy consumption is. What is different is the urgency. Between AI and data centers, buildings, and all the energy generation, I'm excited to see more and more people here because there's now a sense of urgency and a spotlight that's been put on this than was different from just a year ago. Take a look at a little bit of these numbers. If we start with the data center construction in North America alone, which houses the vast majority of the world's data centers, grew 46% from 2022 to 2023. The projected numbers in data center are large. I don't have to tell you how large. Whatever headlines you're looking at, they are in the billions, if not trillions of dollars for data center infrastructure. It's hard to put a number on what does that exactly mean and how does that translate to our business and our day-to-day. But then you look at, well, is it a linear investment? Is it just more of the same? And the answer is no, because liquid cooling and the different architectures within immersion and other liquid cooling markets are telling us we're seeing close to a 30% CAGR rate in these new architectures. If you ask most data center operators, like, how do you feel about putting a bunch of liquid in your data center? While it's been around for a long time, it's not something that's been overly popular until now. When you move over to the campus side, here in the EU, it's built into the Green Deal. Over 75% of the buildings that were built prior to the 2000s are cited with poor energy efficiency, and there are mandates to bring that up in the next handful of years, right? These are in the tens of millions of buildings across the EU alone. Buildings around the globe consume between 30 to 40% of the world's electricity, depending on where you're looking. And we know that there is a skilled labor shortage in the skilled electrician market. And so what does this mean? And what role does Cisco play in all of this? I want you to think for a moment about this 40-year anniversary that Cisco has celebrated and what that 40 years represents. Those 40 years represent 40 years of safely securing your data in your networks around the world. Now imagine being able to network energy in the same way you've trusted Cisco to network your data. Now imagine being able to do that on the same line, same cable. So I want to talk to you a little bit today about this concept of energy and how pervasive it is, not only across our portfolio, but really in everything that we do, and this concept of energy networking. First, let's start at the foundational level. We're all key to networking here. If you can't see it, you can't improve upon it, you can't automate it, you can't fix it. So we started with visibility. Over the past couple of years, we have worked hard to standardize across 5 key metrics, and I am excited to say that 4 out of our 13 controllers have standardization in these platforms. Nexus, Control Hub, Catalyst, SD-WAN. Those 4 are alive and on today, and they're available for free in your dashboards. Anyone use them yet? Anyone know that it's available for free today? Awesome. We're working on the rest of those platforms, right? And so regardless of whatever that North Star looks like from a Cisco platform perspective, we have standardization, we have these 5 metrics. Our data foundation governance is so important and critical to Cisco, and so you can count on the credibility of telemetry of these 5 metrics. How much you're using, what does it cost, the energy consumption, greenhouse gas emission in that location, right? These are all geo-tagged. What the energy mix is, how much is renewable, non-renewable energy in that geolocation, and carbon intensity. These 5 metrics are available for visibility for free across our platform. This will only get you so far. Visibility is great. Visibility gives you insights, it'll give you some analytics. Eventually we'll get there, get to automation. We're going to continue to partner with Splunk, a lot of great things that come from this data. But they often say it is necessity that is the mother of invention. And I am so excited to be able to talk to you today about some of the inventions and some of the things that Cisco as a technology company continues to pioneer. If you were following along at all, you may have heard me talk about this new invention before. You maybe see me carry cables in my little bag when I do customer briefings. But if you take a little bit of a history lesson, About 100 years ago, there were current wars between alternating current and direct current, between Tesla and Edison. And DC is great, but how many people would play with high voltage DC at home? Not a lot. There are a lot of 380 volt DC systems that exist today. Those take those highly skilled electricians. 8 years ago, the same engineers that architected power over Ethernet, show of hands, how many people are familiar with power over Ethernet? Yep. Physically, it tops out at 100 watts. You physically cannot do more than 100 watts on the same line. And when Cisco 20 years ago said this PoE cable is going to take over and replace all of the telephone lines, how many people believed them? They not only took over the telephone lines, video, we added video streaming and more, right? But again, 100 watts. There's only so much you can do with 100 watts. So those same engineers were asked what comes next. And this is the time of the presentation, if you are at all interested in what comes next, this QR code will take you to a white paper that was released less than a week ago on fault managed power. Class 4 fault managed power is what comes next. This white paper talks to you about exactly what that is and how it takes up to 450 volt direct current with unlimited wattage, yes, unlimited wattage, and it is touch safe, just like PoE. Now, the first question I often get asked is, how is that even possible, right? And it's possible because it's pulsing current such that before an arc can form, it will detect whether or not there's a fault. So like 1.5 milliseconds on, half a millisecond off, and if there's a fault, it will shut down. As of 2023, this has been written in our National Electrical Code in the States, which sets precedents for standards around the world. This is a standard, right? This is something that we have to work on together. It's like finding the invention for the seatbelt. When you have discovered a revolutionary technology that effectively offers better, faster, safer, cheaper power distribution, who else would you trust to network that power with data so that you can now start to control this end to end? When you think about the art of possible of what you would do with high voltage DC. You may or may not realize that most renewable energy is DC native. You may or may not realize that we have been shipping power supplies across our portfolio that are 380 volt DC native. This is all in preparation for what's to come. So think about art of possible inside of the campus environment, powering the backbone of all of our appliances in the data center. We're going to look about a little bit of that today. So let's move from power distribution to this other really big problem inside of data centers. Half of the energy in data centers are being used to what? Cool the devices. That is wasted energy. So anyone who is familiar with data center metrics will see that anything that is going to cooling or the fans, that's not useful energy, right? That's not calculated in a positive way in the PUE ratio. And you may think today, okay, well, what's the density of a typical rack in your data centers today? Somewhere around 10 kilowatts a rack for most customers, right? Legacy data centers, and then enter inference, enter AI training, enter larger workloads, enter edge computing. And now all of a sudden, we're looking at densities of racks for over 100 kilowatts, 200 kilowatts. Hyperscalers are getting ready for over 300 kilowatts of density per rack. That is not possible to be air-cooled. If you peek into the roadmaps of the GPU chips, it is not possible to air-cool what's coming on the roadmap from the NVIDIAs, the AMDs, and the Intels of the world. And so here on the show floor today, for the first time, I am ecstatic to be able to show, and hopefully you can see, immersion cooling on the show floor with Cisco equipment. UCS in our compute, the only pluggable optics in the industry that are fully immersible with a rubber ducky on top. So let's move to how to future-proof these investments, right? There's some great new technology, great. When is it available, when is it ready, and how do we start planning for this? So let's start with the data centers, right? If we know inside of data centers, the largest expense is electricity, and we're talking 46% of that total spending for enterprise, and up over 60% in data centers. again, these rack densities continue to go up. And the operational efficiency of being able to do energy management, whether it's in our Nexus dashboard or our Insight dashboard, these are things we're actively working to standardize. A couple of years ago, we talked about our routed optical networking layer of converging the network. And I want you to take a look at some of these metrics. When we talk about sustainability and engineering at Cisco, it's something that is ingrained and embedded in everything we do. So you might say, hey, we're not hearing sustainability on main stage anymore. It's because it's embedded in what we do. Just like you expect your data to be secure, you don't need to be reminded all the time that we're going to try to do that the best possible way and the most responsible way. It's the same thing with sustainability. And these metrics are mind-blowing when you think about what's possible with the convergence of the network. The performance, the energy efficiency, the space efficiency, the pluggable optic that G2 pulled out of his pocket earlier this morning. So if we take this concept for routed optical networking that connects most of our internet and most of the service providers, and then we look into the data center, what is possible? So inside of many of our labs, I want you to just take a look at these numbers. It was in graphical form. I said, let's just spell it out for people. The energy conversion loss inside of data centers is well over 40% when you kind of add it all up. So think about that conversion, AC to DC. Every time you do that conversion, you lose a couple of points. And how many times are you doing that inside of a data center? 3 to 4 times at least. If you think about, we talked about the classical fans. How many fans are inside every server, right? And you put those servers together, all of a sudden, you no longer have a space problem, you have a heat problem in your rack, right? And we're hearing this more and more from customers. And so when you add this together, even something like basic power factor, and how clean and what you're doing to address the various phases that are coming into your data center, all of this introduced because you have AC and DC all in your data center. Now imagine taking the two technologies I just talked about, fault managed power and liquid cooling, and the art of possible when you pull that together and you start looking at what gets unlocked in terms of energy efficiency in the data center. And the back of the envelope math that we saw in our labs is over 50% of energy unlocked inside of a data center. When you start to break down the silos and you bring these systems together to optimize, and again, energy management at that foundational layer will give us that baseline. So wherever you are today, the question is, where are you going to start on this journey? So let's take a look at an architecture. How might this look in practice, right? Art of possible. Fault managed power in a data center today. You can go top of rack in scenario 1. So you look at fault managed power and then you look at the battery and energy storage systems. We're seeing some of the hyperscalers today look at scenario 2, right? One mega hyperscaler in particular is doing that full kind of aggregated by row, disaggregated power. So you'd have bunch of racks of servers, and then at the end you'd have one full stack of disaggregated power looking at fault managed power. And they're looking at, again, upwards of 400 plus voltage DC. Scenario 3 has centralized. It's all completely centralized outside in a contained room. Scenarios 1 and 3 start to unlock over 30% of energy savings. Scenario 2 is closer to about 10, 15%. Right? And we're starting to see the hyperscalers look at this, and we're starting to see what becomes more and more accessible at the enterprise side. When you look at where you might start today, we know that air cooling tops out around 16 kilowatts a rack. Rear door heat exchangers and CDUs, whether they're in rack or at the end of row, you can start to unlock up to 40 kilowatts a rack. Direct to chip gets a lot more interesting, and there's a lot of different, single phase, double phase, open loop, closed loop, and so we're starting to see some of that convergence. We are looking across our portfolio at how do we work in direct to chip into our portfolio so that this becomes a transition state. And then, of course, the transformative state. The number of customers that have actually come and asked, it's actually quite interesting, especially as we look at more and more edge computing. Immersion tanks make a lot of sense for edge compute, especially because we can now look at dunking in the labs switches in addition to our compute, in addition to our optics. So here on the show floor today, we have 2 different immersion tank vendors showcasing this. When we look at the broader ecosystems in which Cisco infrastructure is built, we know this is not an ecosystem that is just us. And I think what's really important about this picture is just the pace of scale and speed in which we are designing these partnerships to go across everything from cyber resiliency and cybersecurity to hybrid cloud to storage. And the liquid cooling pieces are coming pretty quickly. The other piece that we're starting to see, and I mentioned edge compute, is data center and enterprise and campus are all starting to mix together a lot more. We're starting to see more and more on-prem in the data center because AI training and AI inference, people are wanting closer to, to where they are, whether that's hospitals or banks. And so here's one customer example that is a bit world-class, and I want you to think kind of art of the possible. If this is possible here, where can it be possible in your environments? Let's roll the video.
This story is not about buildings, but redefining how people build things. Big things, like reimagining the once iconic Hollywood Park racetrack into a world-class destination for living, working, sports, and entertainment.
Architecture used to define spaces. Now it's equally about IT infrastructure. Partnering with Cisco, we've built a single, powerful, secure network that connects everything from broadcast systems to ticketing, security systems, and HVAC.
We have a converged network of intelligence with unprecedented control and visibility over our 298 acres. Since 2020, we've tapped into nearly 1 petabyte of data. We've solved problems even before they exist.
When guests visit and millions of people watch from home, the experience needs to be unforgettable. Everything behind the scenes must work flawlessly, and it does. This isn't just smart, this is revolutionary.
This story is about building revolutionary things, like SoFi Stadium, the most technologically advanced stadium on the planet. It's where 70,000 fans scream and stream at the same time.
At our big events, fans consume 32 terabytes of data without slowdown. And Wi-Fi powers everything, from the essentials to the innovative. It helped us improve navigation, reduce bottlenecks, and more.
The network empowers our broadcast team and our partners to seamlessly control and route thousands of video feeds throughout the Hollywood Park campus. This connectivity is truly transformative.
This story is about transformative things for the people behind the scenes.
With Cisco, we have the network and compute to scale operations and fan experiences. We're pivoting easily from intimate events to the world's most notable experiences. With full coverage through the network for both front and back of house, we could do anything for concerts, game days, and events. We're creating a dynamic environment while blocking 150,000 malicious threats annually.
The network has saved us millions, including reducing energy costs. We also cut our infrastructure data center footprint in half with Cisco. We can keep building.
This story is about building and building.
We started with SoFi Stadium, then YouTube Theater, followed by 900,000 square feet of retail space and 25 acres of communal space. Expansion used to mean new networks and countless days of work. Now it takes hours, and everything is routed and ready. We keep building without missing a beat.
Or a championship.
Or a medal. With Cisco, we have a partner and a blueprint to build the future.
What was so fun and incredible about this example is the data center was built for SoFi Stadium, and with Hollywood Park, where the 2028 Olympics are going to be held, they don't have to build out anymore. That one data center with the footprint cut in half is going to expand across all of Hollywood Park. So think World Cups, think world stage. If it can be done at this level, data center and campus architecture with Cisco, end-to-end experience. It's a phenomenal thing. If you're ever in the LA area, visiting SoFi Stadium or seeing an event there is pretty spectacular. So let's move over to the campus, right? Future-proofing the workspaces and Cisco's architecture here on the energy side, same thing. The low voltage DC deployments across leveraging PoE with every endpoint, every camera, every sensor becomes completely automated. In a stadium of that size, or any stadium that is near here, think about how much wasted energy there is if you don't have the right automation and segmentation in that environment. In the US alone, we cited $4.7 trillion that are coming up for refinancing. It's sort of a world crisis, if you want to look at it that way, with return to office and post-COVID, unprecedented in its history of how many buildings are coming up for refinancing. So what a lot of these owners, landlords, and operators are looking at is, what do we need to do to these buildings to bring them up to code? When they were built 30 years ago, internet and Ethernet was not a utility. Today, they often refer to it as the fourth utility. And so we're starting to see these smart building projects climb worldwide. And if you look at that campus environment, you may not think of it immediately as a smart building, right, with SoFi Stadium and Hollywood Park, when in fact the demand of these types of projects continues to grow. What's fascinating is there's integrated solutions across a much broader ecosystem. So when Power over Ethernet first came out, there was some hesitancy in the practitioners of like, we don't know how to cable this, or maybe it's going to displace some of the labor. Now we're seeing completely integrated ecosystems. When you hear the term DC microgrid, or you hear the ability to plug everything in with Power over Ethernet, what that means is it's connected to the network, and you can completely automate it, just like you would automate your network today. And the stats that we're seeing, the real customer examples that were coming back, if you heard earlier today with the service providers of Swisscom and Deutsche Telekom, the numbers that they're seeing in energy efficiency are an organic part of the business. And if there's one thing I would urge you to think about is, we're not talking about just sustainability anymore. This is just good business, right? And energy savings, depending on where you are in the world, energy costs will continue to rise. And so how are we going to curb that, and how are we going to use technology and automation in the network to help us do that? When we think about fault-managed power in a future-proof workspace or in the campus environment, on the before side, you see a lot of the AC and DC conversion again. You see a lot of conversion loss and power factor being coming into play that really suck up a lot of that wasted energy. If you think about using fault-managed power to plug all of the appliances, and then PoE to go that final mile in an office, this is effectively what Cisco is doing to its footprint in real estate, office by office around the world. And it's something that we get to talk to our customers about. And what's fascinating about this architecture is it will completely show you an end-to-end microgrid, right? A safe DC microgrid. Some people will say, okay, well, what about all of the skilled electrician labor? We still leverage them. We might use them to do the final hanging of larger fixtures, and then we have basic cabling like PoE for the rest of it. We're also saving a tremendous amount in conduit steel and all of the cabling that goes up into the ceilings that you can start to open up. So you actually have even more space in the ceiling when you start to use PoE for that final mile. And so what we're seeing is an entirely new ecosystem of partners developing PoE solutions, low voltage energy systems, and this is getting pervasive across the industry, right? So new standards are now coming about for PoE consortiums, alliances, and standards for low voltage energy systems. And it really, really gets exciting for a company like Cisco to be able to network that energy across some of these large names that you see here on the screen. And all of these come together in a smart building. Most buildings today have to manage well over 30 different building management systems. When you take the architecture of a network and a Catalyst 9K in your backbone, that number comes down well to under 10. And so we're really excited to also say in the last year, since we were last here, we've developed a very specific program called Engineering Alliances to help us build out these ecosystems, to de-risk the environment for our customers, to do truly engineering validated solutions with lighting manufacturers, motorized desks, blinds that have solar integrated into them. Right? In the data center side, immersion tanks, rear door heat exchangers, we are going to validate all of that in third-party labs and validated solutions, come out with technical briefs and solutions, and offer that to you at scale. We formalized and announced this program at Partner Summit about 6 months ago, and since then we've already signed 7 new partners, offering the 4 use cases you see here on the slide. What's very exciting is most of these use cases are demoed in the sustainability zone here at Cisco Live. And so if you have not yet had a chance, I would encourage you to see what fault-managed power looks like powering a switch, and then PoE powering all of our endpoint devices, including some of the new partners that we've signed into engineering alliances. I'd encourage you to look at not one, but two of the immersion tank vendors and watching and seeing what it looks like to run the CPUs at 100% at over 10 degrees cooler than it would if it was air-cooled. In addition to that, you might say, all right, well, this is an industry piece. Like, there's a lot of standards at play. We've also been really busy in the standards and trade organizations. We at Cisco know more than anyone that it's not just IP that's important, it's building and creating the safety standards for the industry at large. So we have things like we've joined Open Compute Project as a platinum sponsor, because Open Compute Project is no longer just at the hyperscaler level, they're starting to come down to enterprise. And this starts to include things like open, modular, interoperable systems for the data center. NEMA is the National Electrical Manufacturer Association. I now sit on the board of that, and it's a lobbying organization, it's a trade association, and they have a standards board, right? And so when you think about an 100-year-old electro industry that is ripe for transformation, pulling in new technologies like low voltage systems for PoE and fault managed power, this is disruptive, right? And if you're just learning about this, I'm so excited, and I hope you tell 10 of your friends, because these are standards and these are things that take time, but they're going to come at speed and scale out of sheer necessity, right? We don't have enough power to power all of our systems. Imagine saying, hey, we need to go build this new data center in this town. Unfortunately, that means residents aren't going to have enough power during these hours. That's not a trade-off that we should be tackling. It's the same thing for other limited systems like water, right? And data centers can actually consume quite a bit of water if not architected the right way. So left-hand side here, you see a lot of the standard bodies and organizations in which Cisco plays founding role, membership role, or a board role, because we need to bring all of these standards and industry partners together. On the other side, this is a great example here, very close in region, where we're starting to expand and have these conversations, not only with our NetOps traditional IT buyers, but real estate, facilities, procurement, and the C-suite of organizations are paying attention because they are making these active decisions on real estate. So Project 150 Holborn in in London, is a consortium between Cisco, Sadara, Schneider Electric, Ideal, and Para. And we're continuing to lead in the industry looking at intelligent ready buildings. And Cisco can't do this alone, right? Whether it's Schneider or Honeywell or Johnson Controls, a lot of these building management systems are ripe to start to talk to each other, to be disrupted, and to be more automated with its energy control. So this concept of integrated energy systems is really exciting, and I hope that some of the newer technology and innovation that we've presented here today give you a little bit of that art of possible, and that you can start asking questions, because it's going to take all of us. I'm standing up here today by myself, but I guarantee you there are teams and small villages of people that have made all of this possible and continue to make this possible. And it's so exciting to see the progress year over year, specifically at this conference, where not only energy management and sustainability are so important, but it's so ingrained in the resources of how the government and the private sector think here, which is just to be responsible about its resources. When we look about our end-to-end programs across Cisco, our refresh program is 24 years strong. Our supply chain allows us to take back 99.98% of everything we take back can be recycled or reused. We have patents and IP on some of that take back and recycle processes. Our partner specialization program now has over 1,000 partners in it, and that program was only started a few years ago. So very, very, very excited to be here. It's a tremendous milestone every year to talk about the progress we've made, and I really encourage the feedback and the guidance and the partnership, because we truly are on this journey together. Thank you so much.